Okay, great. Thank you so much. Thanks, everyone. Good evening, and it's my pleasure to welcome you all for today's session on Edge Compute. Indeed, it is my pleasure to welcome Prakash Ramchandran, who is the co-founder of Emerging Open Technology Foundation, and he has been leading edge services and platform for open source and commercial organizations. With MTech in electrical engineering from IIT Bombay and 40 plus years of experience in ICT industry, he brings in the passion and steady hand to streamline the challenges faced by the industry to make the edge service and the platform automation a success. His experience includes startups, ISPs, ASPs, system integrators, various telcos, mobile specific applications, public and private cloud deployments, research and development, and so on. He has also led various open source efforts for edge compute with OpenStack and Carnegie Mellon University, CMU. He is also a chair of IEEE NFIC 2018 and a senior member of IEEE. He is an independent member of board of directors from 2018 to 2020 for the same society. 5G and Kubernetes SME at Dell Technologies. He has been volunteering for various uh, uh, conferences on emerging technologies, uh, be it OpenStack, LF summits, or open source forums in Silicon Valley, India, China, Europe, and he has been known to lead large and complex deployments of open source technology. Uh, so thank you so much, Prakash, for joining us. Today we were to have a presentation on quantum compute by our common friend, Professor Gokhale. But due to health exigency at his end, we had to change the topic. And at a notice of less than 30 hours, Prakash has been kind enough to agree to deliver a talk and join us while he is traveling on some social function. So, thank you so much, Prakash, for joining us, and it is our pleasure to learn from you, sir. Welcome to TMI Community Webinar. Over to you, sir.
Thank you. Is there any share you are able to see?
Yes, we are able to see your screen.
Is it showing Edge Native service?
No, it is showing the Google Meet screen. So you'll have
Okay.
to go to the deck.
Okay.
Yes, now we
Now,
are able to
Yeah,
see.
yes, sir. Yes.
so
Yes.
there will only be one screen I'll maintain so that all of you get familiar with exactly what I'm trying to express. Because first thing, cloud. Cloud is a noun. Because when I say cloud, everybody understands cloud means you got something data network where you got something the resource which you want to seek. The resource could be a server, could be a container, could be a VM, could be an application, could be some content. So essentially, cloud refers to the data network where some resource is available which you can use. Now comes to edge. So what is the difference between cloud and the edge? Edge is also a noun. Person, place, or thing, as you say. So it's a thing. So edge. Um, so when we talk about edge, so I am going to say cloud capital and edge capital. Both are capitalized term. The difference between the edge and the cloud. What is edge and what is cloud in that case? So cloud we describe, most of us know when we say cloud, it doesn't mean the water, the rain cloud, but rather a cloud which is data center and data networks connected together with the universal network, which we call it as networks of networks, the internet. Edge, on the contrary, is so cloud. Generally, cloud, when we say the data center concept, is a what we call as hyperscaler. What it means, it's a huge and it's massive. You got hundreds of thousands, thousands of and 10,000 and hundred thousands of servers, uh, public cloud. I mean, in the public, which can be accessed. And the popular ones you have heard about Google Cloud, which we are using currently. Then you have got the uh, what you call the public cloud from Amazon, which is the most uh, what you call talked about because they were the pioneers. And then you got the standard Yahoo Cloud. It could be Tencent's, it could be Alibaba, it could be eBay, it could be Antar Megha of India, it could be Badal, old Badal of India. So cloud is generally perceived as a massive, centralized, logical view of resources connected together by internet. Now, edge is something which is more to do with local. Basically, if you have, uh, obviously, you are, a lot of you are from Bajaj Institute of Management, you know that is Mumbai. So you got here a cloud which is uh, used to be provided, some of them by local players. So it could be that you are going to MTNL or GC, those kinds of telco providers like Vodafone, Reliance. They are providing something in the. Uh, you could be using Facebook. You could be using. So essentially, you access a cloud, and then, but at the same time, edge is anywhere. Why edge is anywhere? Because if I try to tell edge that I am giving you service delivery from edge, the question comes is, where is the edge? So edge can be just in your own house. You can have your own data center with one server and being connected to the internet. So that means you are a on-prem. On-prem cloud they call, or you can call if you are getting delivery from, you are serving somebody. You are using is different internally, but you are exposing your services to outside. So this is a on-prem. So on-prem cloud, which is private cloud, or it could be a public cloud. Now, question is on-prem cloud a edge, or how do you describe an edge? So edge is normally treated as a resource being available, delivering to you locally in real time. Now the real time can be different. You can have real time of, you can see in the figure here 0 millisecond, it says at the left top, left bottom. Then you got 5 millisecond, then you got 10 millisecond, then you got 20 millisecond. At this time, cloud generally we say will have minimum 20 millisecond of latency or delay. So you will have, like I am now here in LA and you are in Mumbai. We have got, uh, in terms of kilometer, we may be maybe 3,000, 4,000 kilometer, or thousands of miles as they call here. So the last mile between us, we have got a huge distance. Now, even if you have light travel at the speed of 3 into 10 raised to 8 millisecond meters per second, still, even with that, you still have some kind of a time difference, or there is a delay when we talk to each other. So that is the delay we are talking. How much it is? It's in milliseconds. 150 millisecond used to be the one which was the common figure used for voice, sound travel, and coming back. Now, uh, so the distance always creates a delay, and when we have media, the media example currently I am talking about, sound. Similarly, you can have video, you can have data. So different kinds of media take time to reach from a point to another point, whether you do it through a hardwire like we used to do in case of old plain old telephone pot, or we go through internet currently, and that is what creates a problem for the applications that are hosted. When you say hosted, means you are putting it in the internet, and the cloud is connected to internet, and so is edge connected to internet. But edge is closer to the proximity of the user. So if I have something, I have edge at Mumbai, I can have edge at Pune, I can have one at Vadodara, I can have one at that is Western region, or I can have in the South region in Chennai, Bangalore, and whatever. So you can have edges in different locations. And when we talk about the edge, the difference between the cloud and the edge is latency, latency, and latency. So the term edge is in the proximity of where the user is, and there you can get uh, low latency. Uh, I can say sub 5 milliseconds, sub 10 millisecond, or sub 20 millisecond response time. So usually when if somebody wakes me up, example alarm, I will take at least 5 milliseconds to respond back. So there is a human response time which is very important. So response time or latency is the key term. So edges are all over. Why edges are all over? I am driving a car, let's say. Okay, I am sitting in the car and driving, and then some program has to fix me, saying that, hey, why are you wavering around? Why don't you go at the center? So is this going to be done by machines? Sure, why not? So that is where the lane correction application, which could be running uh, in the car. Now, how does it do is different thing. Let's talk about what is it doing. It's trying to fix that you don't waver off from your road. Now, this is a edge. So car is an edge. Same way I talk about, let's say, a field. You are in Nasik and you are a grape grower, and you got a field which is uh, thousands of whatever meters or square meters or whatever acres field, and you got sensors which will sense the climatic condition, that is whether it is uh, you got grape which needs to be watered at the right time at the right place for it to be blooming, so that one can manufacture whatever you manufacture, a juice or a whatever you can produce out of it. So essentially now if those sensors sense something temperature, and you know that at this temperature you need to, or this temperature or cold, this is the time when you need to put water. So there is a frequency at which you will put every day, uh, maybe at 2 o'clock when it is hot you want that to be uh, watered. So you got a either a sprinkler or whatever the system which whatever, irrigation system. So you can put that drop the water at that time. Okay, and then that can be distributed. It will done every day 2 o'clock. It will do 15 or 20 minutes. That could be one way. Another way could be just sense when the temperature is at certain degree. It can be any time of the day. You just drop the droplet, which you do in the irrigation. So these are edges. So this is field is an edge, which is a fixed edge in this case, whereas it could have been the mobile edge in the case of a car, and it could be your on-prem where you have something like, example, you are producing something and TV type of content, and you want to deliver to yourself and to others in the neighborhood. So you may have a studio and you can do uh, what you call the movie which is being transmitted within the society or within the region which is the edge. So what I've put in the heads, edge and cloud both are different. Cloud is massive, exists in the data centers, huge, humongous data centers, and they are called as hyperscalers data centers. You can see on the right side, whereas the edge is in the nano and micro data centers, which are to the left side of the picture. So now coming to, uh, I will start with the left and go to the right. Left side 0 millisecond, those kinds of applications are required for smart city, because if you have a car, uh, automatic vehicle which is being driven, then you need something response time which is under the 0 to 5 millisecond range. So your smart city applications, traffic management, intelligent traffic management, those kinds of applications require a low latency, and there are standards for that. There is always standard for many of them, but software is what matters, because software drives and the hardware obviously. So you need the two components that you need to build a system which is either a autonomous system or a uh, automated system which can provide some kind of a application to consumer or to the enterprise, that's that can be run for different applications like IoT. IoT is Internet of Things. So the one which was I explained to you about the agriculture application of uh, the automation, and why I am saying automation. A little bit of terms we'll have to understand clearly. Automation. What does automation mean? Automation is generally when you have something which is in the physical in nature, and you are trying to do some kind of a electronics to automate that, like your metering, water metering. So if you have a meter for your house in the water that is at the edge and you need to automate it, so you need to follow the process. What is the process? So when a water goes through the pipe, then you have to measure it, and that means all the Bernoulli's and all those principles which are used to identify the volume, weight, and all that is metered. And then once you meter, then you get for this many cubic meter of water, this is the price, and therefore you pay for it, etc. So that is one application of metering, which is a water meter. Now that can be measured and also can be built. So if somebody just walks through with a meter reader, and if there is electronics, whatever blue, uh, either you are using a Bluetooth or whether you are using some kind of a access, somebody comes and just like a barcode like thing scans on your meter, and then prints out the bill on the spot and delivers to you and keeps walking. So this could be a part manual, part automated. It could be automatically being electronically being received at the water management center or water purifying facility, where they purify and pump into your pipes and you receive it. That may be built. So you can have water metering of that kind where you measure and pay, or it could be just you get between certain time and certain time the amount, and then you pay for it, and they measure and then you pay for it. So edge as such, applications can be varied applications. So it can be, the use cases can be varied. The normal use cases which we uh, talk about are AR, VR. AR, VR is augmented reality, virtual reality, because you are playing a game, you're a gamer, you play game, then you go and instead of going to the arcade where you play game, you can now do it at your house. Just open the internet, start playing the game. You'll have some kind of a, unless of course you have some special devices, Xbox or whatever, you can play with that. So gaming applications are also at the edge, which are in the sub millisecond, 0 to 5, maybe 10 millisecond range. So there are standards for gaming. There are standards for similarly for the supply of um, water. Then you have got industrial IoT. That's a major application. Industrial IoT is like you have got process control systems, which happen to be in the uh, generally, if you go to Mumbai, you have got Waghli estate and you got various industrial estate, Borivali, Kandivali, whatever, wherever you go. You got companies which manage the process. Example, a plastic company. Example, Brimco Plastics, let's say. So what are they doing? They are manufacturing plastic. So they have got huge machines which are being, there is a production planning control. So you use the uh, PL one, that is they call programmable logics. That was the good old days they used to use programmable logic, and it could be a decision control system, it could be operation control system, because processes, similarly you can go to, let's say, uh, Bhandob side, there is a Hind rectifier. So what they do, they are producing rectifier, so they manufacture the, what you call the transformers. So transformers need to be uh, tested properly, they need to be wired properly. So there is a whole slew of processes in the process control system, whether it's a plastic industry or whether it is a transformer manufacturing or any industry you take. All industries require a process, and there is a standard called ISA 95, and then that describes what you need. So this is uh, what are the various processes. So layer 1 process, layer 2 process, layer 3 process, layer 4 process. So business processes are at the top, whereas the physical virtual processes which are based on the hardware, electronics, and the software is at the lower layer, in the link layer, Mac layer, what they call. So depending on the process, the process needs to be reliable. It needs to be ultra low latency. You can't have a whatever a lathe machine being operated and suddenly it will it will not cut at the right time. Then you will get all defective products. So basically, it is programmed. We used to use with tape programming. Now you can program with directly through the digital means, which is what the digital transformation has been. So what has happened is in the industry, uh, these are the various use cases I tried to just describe to get you to the point that, okay, we have a edge and we have a cloud. Cloud can be distributed, edge can be distributed. Edge is more local, edge has proximity to the user. And the reason for that is because you want a faster response time. However, the computational constraints are there when it comes to edge. In edge, in a house, you can have only so far. You can have one notebook, two notebook. Maybe you can have some electronics like your programmable logical controller for the manufacturing. So there is a cost to it. So there are factors that differentiate the edge and the cloud. The factors are cloud at least appears logically to be resourceful, abundantly resourceful, in the sense that you will not have shortage. You will never feel the shortage of it. You can ask for whatever you want, you will get, and you can possibly the three factors which always govern the data centers, that is the power, the infrastructure, and the cost of the location where you are implementing or deploying the data center and the internet connectivity. So you will find that power, cooling, both are important, because you have to keep cloud under a certain environment which is cold, less than 20 degree, or approximately in that range, 20, maybe 15 to sorry, yeah, 15 to 22, 23 degrees centigrade. So you have to maintain the temperature because electronics require that. So the temperature, which is power, again the servers and computers, which is equal to storage, which is equivalent to network gears and all that, they need to be maintained. So there is a power, one server around 250 watt. So if you got thousands and thousands, you need kilowatts, and sometimes it is said that the rate at which the growth is occurring, and especially you need to uh, have, in fact, you go to the data centers, big data centers, there will be a power generator, there will be a power, so they try to locate themselves in places where they have got, like maybe Khopoli or whatever Khanda, those area where there is a in between Bombay and Pune, there is a big, huge power supply station. They would like to locate there because the cost of energy is important, transmission is important. So all the big data centers are more uh, power hungry, and they need cooling. They need a lot of infrastructure. They are massive. Cloud is edge is not like that. Edge is, it is constrained environment. You have to take a box and throw it. Example, if I have a traffic control system, and in the traffic control system I have to make sure that traffic lights are switching on and off, bright, green, red, depending on traffic. So monitoring the traffic and putting, now I cannot think of their creating a data center at every place in the world on the roads. So on the roadside there will be a just one single server, maybe a box of like your pizza box or whatever, dosa box, whatever you call, of some smaller thing, and some electronics will be there, and that will be just we call 1U factor, 2U factor, rack unit we call it. So one rack unit is around 1.75 inches. Convert that to centimeter, whatever that is, 2.54 centimeter into 1 point, let's say approximately less than 5 centimeter. So if you have a box which is just 5 centimeter by 20 centimeter, 100 square centimeter, and then a depth of around another, let's say another 20 or say around 50 centimeter to 100 centimeter maximum meter, and that kind of a box is resident at different traffic lights, and that can manage the traffic. So that is a edge now, and the constraint is that there is no air condition, you can just keep it there. It has to be industrial strength basically. So edges require something which is uh, industrial strength. It can be thrown out, it should work, it should be reliable. So the criteria is constrained here, that you can have a temperature which is 50 degree, and still it has to work. It will be sometimes minus 10 degree, it has to work. So basically that means your factor of cooling and all will not be easy to obtain. You have to do fan cooling only, or no, not even fan, because you that's okay, you can do fan. You won't get a water cooling like we do in some of the data centers and all. So essentially what it means is the equipment which is placed at the edge has to be very, very sturdy. It should be able to take, withstand any temperature, pressure, rain, water, sun, cold. So basically industrial strength devices are required to be placed. That is true whether you are doing a edge for traffic control, or even for the grid control. When I say grid control, means power. So you can see on the left side the power grid. So power grid, what is, there are standards for it. So everything requires some standard. Now power grid, what do you do with the standard, you will ask me. Yeah, of course there is a standard, because you got a, whether it is a, 110 volt or 220 volt. We have 220 volt in India, yes, 112, 10 volt in the US, and so there is a difference in voltage. Frequency, one has 50 hertz, another is 60 hertz, so there is a frequency difference. So the design of the whatever your power uh, grid is there, depending on you are connecting what are the generators. You have got your Genie generator, a power generator at home, that is different from the power that has got a different frequency. So basically all these provide, now example, why does power grid come into picture for edge at all? You have a solar energy, so you have got a house, you are mounting on top of the house few of the photovoltaic cells, uh, arrays of it, and then each one of them generates around 25 to 50 watts, or depending on the day, morning, evening, etc. So you produce the energy, and that is converted into, there is an inverter which is nothing but, whatever you get is always DC voltage, on the photovoltaic cell, you convert that into some kind of a uh, voltage, and that DC voltage is maybe you will have 8 of them, 25, and all of them adding together, say 200 volt. Now, or maybe uh, you got 16 of them, two parallel you got. So if you get overall 400 volt, then you have to reduce it. So you have to convert that into AC, because transmission is generally AC. So you have to convert from the DC to AC. So there is an inverter. So you will have an inverter, 4 kilowatt, 8 kilowatt, whatever inverter, depending on how much you produce. And then you convert that into some kind of a AC voltage, which is equivalent of in case of India, you have got one phase, two phase, three phase. Assuming that you have one phase, and then you convert it to one phase of 220 volt, and then you feed it to the. So you are now the producer, not the consumer. That's the big difference. If you are a consumer versus you are a producer, then you have to, when you are producing, why would you give it free, right? You want money for it. That's why you installed you have a cost to recover for as a uh, producer. So you deal with the whatever GEB or MEB or whatever electricity board or whatever you have, and then you provide them, and then they agree to certain pay certain rupee per kilowatt or something like that, and then you have a metering, etc. So it's a producer consumer world, and you can see immediately. Earlier we always think of, oh, transmission is made and I will get the electricity. If I don't get electricity, what do I do? Now you got a option, you can produce yourself, but the question is, how do you um, electricity has to be consumed whenever you produce. It's not like you can hold it unless you have a a battery which you can charge, or uh, it's like a flywheel of your uh, um, machines. So basically, to you have to store the energy. Storing energy is the costliest affair, and that is why people are not able to use it. But you may have your EV example. If you have an electric vehicle, then Tesla or whatever equivalent of that there, and you may charge it. So you can have a charging station which collects the energy, and then you put it into battery, and then you charge it. It may take 8 hours in the night. Who cares? Because in the night you get the power in the day, and it gets into battery, and then in the night you can charge from the battery to the. So you can have a pack of it. You can bring the pack and use. So essentially, what I am trying to do here is say that you can have a grid. So you can use power grid. You can have intelligent transportation system. Then you have autonomous vehicle system. Then you can have example. Right now what we are doing, we are watching a picture, right? So training systems are there. So you got content delivery systems which are in the mid range. So after 5 millisecond, then 5 to 10 millisecond range is where your video content and delivery content management system, training system, massive online computing MOOCs are there. So those are kinds of applications which are in the what you call in the edge. They are uh, typically we call them as make application mobile edge computing, because usually you want it on your mobile, not necessarily the desktop. So you can roam around and you can still see your cricket match if you have got a one day whatever ODI or 50 over, and then you want to watch that for a few hours online. Then while traveling, you can keep watching that in your either car or in your phone or whatever. So those kinds of content, or you could be just listening to people like me who is talking right now while you may be driving, or so it depends. So essentially, what I am trying to give you picture here is that you can have any of these mobile edge computing, which is where you get the edge functionality. The last mile is a mobile device, and that mobile device could be the your cell phone. It could be a built TV in your car for an infotainment system, or it could be a training system which is used for the training of the people you may be learning. So learning management system. So LMS is one of the other applications. So you can have Coursera, or you can use Baidu, or you can have Baiju. What is it? Baiju educational system. So you can have those kinds of educational systems which are very popular. So that is another kind of use case. Now coming down the lane to the how does this get delivered? So because of the 5G, no, I have never seen these days nobody missing that 5G at all. Like IoT and 5G are bundled together for the edge because you require radio access, and once you require radio access, the 1G, 2G, 3G, 4G, and 5Gs of this world come in. And 5G is nothing but throughput and latencies, which are very low latency you can get. At the same time, you can get high throughput. So, latency is the first thing which is addressed in the edge. Throughput is obviously for the mobile broadband type of application, but it can also use it. Example, like I gave you the Coursera and uh, the Byju's content delivery to the kids and all that. So those kinds of educational applications is there. Now there is more to it, but let's assume that we have central offices. You remember central offices like exchanges, your telephone exchanges which are there. There used to be what do you call Prabhadevi, you have exchange, you got one in the other one. So exchanges are centralized location where, which is where you get the connectivity from MTNs and this all these reliances and the suppliers of the internet like Vodafone, those kinds of things. So exchanges now, central offices are now going away. Rather, instead of having an analog exchange, we tend to use data centers as self as a switching center. So that is another way of central office application. So they call it a central office reimagined using data centers, COD or something. So something of those kinds are also available. All of them then provide the connectivity as well as the use of it. So takeaway from all this is that you have got edge, you got various use cases, and they require low latency, and they also sometimes require higher throughput. That is, the bandwidth is required, and the other characteristics which you will find obviously is reliability. It has to be reliable, otherwise people will not use it. So reliability, and then the um, low latencies for the industrial IoT, as I mentioned earlier about the all this PL logic, programmable logic controllers, and all which they used to use. Now they are all using directly the electronics. So those are the things. Now, obviously, I am not talking quantum computing. These are all binary computing. So, had I to talk about quantum, it would have been a bit different in the sense that you got bits. When I say bit is a zero or a one, but if I have, let's say, multi-layer, multi-layer means I have the same. Um, I have got a two, instead of two level, I got four level. Then you got 2 to the power 2. So then you got 0, 1, 2, 3. So if I have similarly 8 level, then it will be 0, 1, 2, 3, 4, 5, 6, 7. So computing as such is binary, but how you build, you can have uh, call it as qubits, which is what quantum would do. So all these electronics are based on binary, but normally when you try to do multi-layer, then the question is how do you do that? And that is where there is a discrete system, there is a continuous system. Even in industrial IoT, you can talk of SAPs and the oracles, and then what it comes down to, you got the uh, discrete system, continuous system. So that's the kind of difference. Digital, you always do everything discrete, whereas in continuous you do analog. That means if I have a watch which is analog, it goes continuous, right? You can see the clock moving 0 to 24. Whereas if it is digital, then you will see every second click, 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 click. 60 seconds you get one smaller or whatever the hands move in your clock. So there is a difference between quantum and uh, binaries. We are talking binaries, they talk qubits. So the computation is definitely going towards the quantum, and which we are not there. We are currently only focused on the cloud and the edge utilization. But you can see that where do I need it? Example, I don't have edge use case, but I can generate one, or at least point to you where would quantum be used compared to what we are talking now. So in the case of quantum, what happens is you will need some kind of a uh, mm, computationally, very highly computational intensive. So example, now we are talking, right? I am talking, you are listening. We may have some kind of a encryption required, because access is one of the key. Before you start anything, a cloud or a edge, you need to access. Once you access, then you have to authenticate. Who are you? Who am I? Who are you? Are we allowed to be connected? Who is paying for it? How is it being paid? So you need AAA function we call access, authorization, and authentication. Access, there are two accesses. One is user access, another is application access. So there are two entities. One is the user. User is obviously, in this case, we are talking of user being a human being. User can also be a automated device. A machine to machine can be accessed. So you can have machine to machine access, human to machine access. You can have same way authentication and authorization. So I know that, hey, you are Prakash and you are Chintan, both are talking, and then they are at different ends of the connection, and then both of them need to be authenticated before they can talk to each other, because somebody is paying for it, and it is being internet anyway, your internet provider is enabling, so they have to authenticate. So same way you got ID management from Facebook, ID management from Aadhaar, ID management from various agencies, enterprises. So you can have a public ID, private ID, whatever kind of ID, but that needs to be, somebody has to identify that, and there is a ID number associated with it, and that has to be validated. And then when you do validation and then you allow a channel to be created, then you have to allow, make sure that those nobody can hear. I don't want somebody interfering, entering into this and trying to figure out what we are doing. So what we want is, we want to encrypt the data, or you want to compress the data and decrypt the data. That means, so you can add some code so that nobody can see, and you can do some kind of a ciphering, we call it. You can have a PKI infrastructure, that a public key infrastructure you can use. So essentially, you have to do some kind of a coding and decoding, encoding. So so that the other people cannot trap, find out what it is. So that's the security aspect of it. So whenever it comes to security, you need the highest level of security, whatever you can afford or whatever you can generate. So generally you say, oh, we want a 256 bit, I want 1024 bit. And maybe now if you find that people are cracking it, because people are always going to detect your data, it's all packets, right? At the end of the day, we are doing digital transmission, which is a bunch of packets or bits and bytes. That is where the quantum differs. But let's just assume right now we are on the digital era with binary arithmetic or binary logic. So whatever bits we are getting, whatever we are talking is converted to analog. So I am talking, this is voice, which is analog. It is converted you to digital using a digital analog converter with a sample and hold and convert that, and then uh, encode it based on media, whether it is a MP4 or whether it is a audio, whatever coding you got coded. What is the frequency? 3 kilohertz for me. I am not a Lata Mangeshkar whose voice can give you 30 kilohertz. So based on that frequency, then sampling and then converting it and uh, coding it and then transmitting it and then receiving at the other end, then decoding. So all these require computational. And if you talk about security, if you have a quantum, you can do multi-layer. That means instead of binary, if I have got 1024 bits being processed simultaneously, parallelly, you can see that is the impact. So basically, if you are using qubits, then the conversion is faster and it is easy to crack a code. If you have, I am using binary code and you are using quantum, you can do at such a speed, the entire thing you can decode it. So you can try all trial and error, you can crack me in no time. So the danger of quantum computing to the binary computing is that it will crack whatever codes you do. So it's a security hazard for us. So we have to be very, very cautious about uh, coding, decoding, encoding. So those are the kinds of thing which is happening for media. So when we are transmitting media or receiving media at the edge or even in the cloud, you need to do inline encryption, because we want at the spot wherever you are doing anything, first thing is you convert it before it goes out, because node to node connectivity, node one node here, one node there in Mumbai, one node here, if we are connecting in between there are so many other nodes it goes through, because it's all packet routing. Internet is nothing but packet routing, and latency is the key. As I said, you have little latency, then you will detect it wrongly. So that means uh, even interpretation becomes difficult. So in the edge computing, one of the major factors is time synchronization. So there are normally in Ethernet is obviously the layer 2, internet IP layer is layer 3, where you talk about addresses. A physical layer is either you have an optical wire or you have got over the air OTA. So you can have workload of different types, and the workloads are distributed, and the workloads which we present are in this case digital. And when we present digital and when we want that resource to be in the constrained environment, we want to encrypt and decrypt, it is harder to do so because you don't have the capability at the constraint. So example, if I want to uh, use, let's say, machine learning in the edge, what do I do? So I want to, what's the use case first? Before even, why do you bring in machine learning here? Yeah, because you are communication machine to machine. What is machine to machine? So there may be one uh, power station 1 and power station 2. The load factor in one place is uh, going down because there are too many consumers, and so you need to get more power from another generation station, bigger one, and to get that you may need to talk machine to machine. So this generator from uh, uh, Worli will talk to generator at maybe in the Kandala or whatever, Kopoli, and then that generator will tell that, hey, here the load is more, why don't you start one more generator and then generate more and then send some kilowatts here. So if they have to talk to each other, it is machine to machine. Now, if somebody interprets in between and tries to knock that off, siphon it off, then that's a danger, right? So this is where the encryption, decryption, all that comes in. So even a simple message that, hey, give me load a generator of 100 kilowatt and send me 100 kilowatt here immediately. That's the request. And this is all automated, okay? And if it is automated, then the edge, we are in early, must receive that. And that means what? That gives you a concept of machine to machine talking. This is also common in robotics. Robotics, like example, you can ask a robot to do certain thing. Switch on the machine and the generator at Kopoli. So you send a message and say, ask it to generate and send me this many kilowatt and at this rate. So now this is a machine to machine talk, and this can also be using robotic. It could be using a actuator. So essentially what I'm trying to drive is, you have got so many use cases for the cloud and the edge and combination thereof, that every use case is different, and each use case requires a different time of response time. Each one has a different constraints, and we have to be able to deliver on all those constraints with so many varieties of applications. Even now, I would have spoken at least 8 to 10 types of applications. Just on the run of the red, I have given you that there are so many applications. And for having all these applications being standardized is a bit of a difficulty. So you have to harmonize the different standards for the edge, harmonize the different standard of the cloud, whether it's a public cloud, private cloud, whether it's a edge which is owned by somebody, and cloud is owned by somebody, and who pays for what. So it is economics. It's a stupid economics we call. So we have to be aware of that. and the nano and the small data centers that needs to be established is sprawling up, and we will see that in India also. In every place you are going to have data centers, and the proliferation of the compute, storage and networking, whether with virtualization, without virtualization, with kind of a high performance. Sometimes they don't care about high performance, they need just computational, or you are offloading certain thing. Like, I may not do it in the edge. Example, I was trying to give it to you machine to machine. When you communicate, then the question is, if you don't have the power to compute in your place to interpret a model, because after all it's all modeling and delivering on the model, because you are trying to predict. Like, example, COVID-19, now you are going to predict, right? So you need data and you collect data, then you have to compute, and then computation. Now this is not just for the sake of uh, what do you call application, like trying to find out the contact tracing type of application. It could also be that you want to really get a image processing, object image. So somebody takes a heat image of yours and then identifies, oh, this has COVID positive. How? Because they can see the difference, they can compare the two images, how the images will be, and so based on that they can determine RNA, DNA, whatever level, and then come up with an algorithm, and that algorithm becomes the model, and you can use the model. Uh, so model can take your temperature, can take your blood content, can see the viral vector, etc. in your body, and then identify that based on this image difference, this is more like COVID positive or not, etc. So even those kinds of high tech application, which is done by usually MRIs of the world, can be even be done with simple cameras these days, because cameras have become very powerful. What you use for security can also be used for your telemedicine and tele presence and all that. So basic edge has really proliferated. And to give you the statistics, in another, the cumulative CAGR rate, cumulative complex uh, rate of growth for the edge is around whatever is currently in the cloud. Just it's just nothing, because 75% of all the data is going to be to the proximity of local usage, and that means edge is going to have 75% of load added in at the rate of almost doubling every 2 years. So you can see uh, a cumulative growth of 12.5 if you take 25, 50, 100. So you are going to get 75% in another 4 years. So by 2024, if you have got 21 and 3, 4 years, if you get um, such a traffic, the throughput, the packet processing of the internet is limited, and plus the computation you can't do at the edge because it is constrained. So you have to offload. So there are two in the edge, two applications which are very common. One is acceleration, which I showed you because of the encryption, decryption, security, and all that. So you need to accelerate. So you get the GPUs instead of using CPU, they start using general purpose. No, sorry, GPU. That is general purpose uh, um, grid computing or whatever the. So in computational sense, there is something called as CPU, central processing unit, and then in the others are all said to be devices, including GPU. So GPU is nothing but you got multi-core. You got processes. Even now CPUs are only 50 core, 64 core, 74 core. So that means you got sockets. Socket is like one socket, and four socket, quad core, 16 core, 64. But GPU start with 1024 cores. So basically you got 1024 processes. And so you offload from CPU to the GPU, then you need memory. I need high memory bandwidth. So the semiconductor technology is really very challenging, and you got end of Moore's law. That means you cannot just double the computation capacity as used to be. So now the question is, what do you do? So you start using GPUs, FPGAs. So you start building the socks on the fly using the IP core. from the firmware, and which is nothing but your FPGAs and field programmable gate arrays. So the semiconductors now are utilizing various devices, smart NICs, GPUs, FPGAs. So of those, that is the semiconductor world. You can change a lot of things where you can do things better and more economically at a distance. So that is where the FPGAs and the GPUs of this world come. And NVIDIA is one of the companies you have heard about, which produces all the kinds of high performance GPUs and all that. Of course, there are others. It's not like it is the only one. You got Intel also, you got AMD. So there are many companies which produce GPUs, and that becomes key for the acceleration. Okay, so one is acceleration, so that you can do how can you speed up something? If you increase the clock rate, then at every clock edge you can do processing. That means you get 1 gigahertz, 2 gigahertz, but how much? So there is a limitation on everything, even in the clocks, even in time synchronization and all that. So there is a aspect of it which is important for the edge, to know that you cannot deliver something, so therefore you need some extra computation, and that can be remote. That need not be in your local environment. That means the edge may not have that capacity. It can offload the work to something which is in the cloud, and the cloud can respond back with the result. So image processing, image comparison, all this, you can have a model, and the model can be run, built and trained, and because you have to do supervised and unsupervised and dynamic, various kinds of machine learning is there. So that can be done in the cloud, and then you can bring it, use those um, models, uh, just send the data or send the aggregated data. So you can aggregate the data at the edge before you give it to the processing at the cloud, and then get back the result and then apply it, and it should respond back within milliseconds. So all that can be done, depends on what is the, if you put a high performance computing, that will definitely do faster. So example, normally the COVID medicine, if COVID vaccine would have been produced in how many years? It would have taken 10 years and 8 years, and drug discovery also similarly 15 years. That is the normal. With all this high performance computing and all that, you can reduce the time frame to 1/10, and so you can do it in 1 year and 1.5, 2 years these days. And if you get to quantum, you will do it much in minutes. All the processing. So therefore, quantum, even though today's topic was earlier quantum, Professor Gokhale could not come. So that's why I tried to explain you that all this is leading towards that. So cloud, the edge, the various use cases, whether they are in the cloud, whether they are in the edge, and so there is a difference between native. When I say native, there is a cloud native, there is a edge native. What is native? Native means uh, if I am taking a physical server and building bottom up, then it is like I am climbing a tree from bottom, okay, and then going to the top. Now what happens if I have an inverted tree? You can imagine. That is like cloud native. So you are hanging to the cloud everything. So that means your processing is in the somewhere in the cloud, and you are just at the edge, and your application is being hosted top down. Service from edge service, which is native to the edge or the cloud. So that means you are reverse, putting it reverse. You go top down, not bottom up. In the case of virtualization, you go bottom up. In the case of cloud native, edge native, you are not cloudifying. So if you have a SaaS is software as a service. So if you have an education application and you are just putting in virtualized and then uh, implementing it, that is called as cloudification. That is not cloud native. Cloud native is you have microservices. That means what? Uh, to connect, I need a API. API is application programming interface. So I have to say connect. Connect where? Connect to where? Edge. Which edge? IP address. This is the IP address. So if I give this for API, I should have a connection application or access application which will allow me to be connected. And so this is just running the API directly uh, from the cloud. So you are accessing the cloud natively, or you are accessing the edge natively by using top-down approach of API or microservices. And every function, like access function, then encryption function, decryption function, everything is separate microservices. Everybody has an API, and you are implementing microservice APIs, and then you are using that to compose an application which is native to the edge or native to the cloud. So you are uh, like I stand up on my head down and looking at the top kind of thing, and that's the way it is. So it is inverted, not the tree but the inverted tree. So you hang your application to the cloud, and you get anybody who gets to the cloud gets to access it, or anybody who is connected to that edge can access it. So that's the way of thinking, and not just thinking, it is a reality. And so as we saw that cloud went cloud native, we believe edge will go edge native. So how does 5G serve it? So before I bring to a question and answer session, I will say that how do you handle the edge in that case in 5G? So there is something called as access management function. You can see on the picture AMFs. Then you got session management function, SMF. So in the case of 4G, what we used to do was we used to call breakout traffic. So your pipe is being connected from the place you connect, and then you open the pipe. You have a V shape or a T shape, let's say, where you got one opening, and then that opening is called breakout. So you can have several T's, but at the same time, each individual junction where you are breaking out and trying to access some resource, that is tunnel. So you establish tunnel end to end, and then application runs between the tunnel so that it is secure. Or you are allocated only the bandwidth that is allocated to you in that pipe. So if you have a pipe and there are 10 flows within the pipe, one flow is yours, the other flow is running, but it is not interfering with your flow. But there may be cases where there like caching services, edge caching services. If everybody is talking of ODI right now, and everybody in Worli, all whole of the societies are watching Shreyas, or somebody who is local guy, everybody wants to watch that. And now what happens? So hundreds of viewers are there, and all are viewing the same thing. So why do a transmission guy has to send uh, 100 sessions? They can do cache it and only one session, and then all 100 people can watch. So they are optimizing on the use of pipeline. So that's a factor. It is not like water where you are consuming. This is just a digital, and your consumption of digital doesn't exhaust because you are seeing the same image. So this is the kind of cloud nativeness. So what I meant by edge native and cloud native is that if it is local proximity at the edge and where there is a scope for optimization. So the problem of the edge is multi-optimization. You have to be able to have low latency, you need to have good throughput, you need to have reliability, and then you need ultra reliability in case you are an industrial IoT guy where you cannot let a robot go amok and do destroy rather than uh, build. So maybe in the dairy where they are, let's say, packaging the milk, you want that it should package continuously, and on the it should come out every area milk colony should be able to supply at 4 o'clock to everybody, so that as soon as you wake, you get your milk at the door. Or if it is a door delivery, even you can drone delivery can be made. So the world is fancy. A lot of things can be done. There is a price to pay for everything, but that is where the volume matters. And fortunately, in India and China, volumes are great, and that leads to edge being cost effectively managed through the access management function, session management function, and the multiple domains of security that is required. So you can have a domain based security, you can have an endpoint pointing to it, where you can click and click to the glory of what you want to view or what you want to get the services. And whether it is machine to machine, or it's man to machine, or human to human, it is a voice, video, data, whatever you choose. And it is in the, and that's why I was I will just end with saying that we have got low latency applications which can be delivered using the edge, and quantum is going to really come in the future, where it does exist. I'm not saying it doesn't exist, but the cost factor, it's like saying that you can supply a what you call the COVID 19 vaccine. If it is a Pfizer and you have to do it at 70 degree minus 70 degrees centigrade, you don't have the facility, right? Whereas if you have a Covaxil or Covishield, which is at the normal temperature, or J&J normal temperature, you can deliver it easily because you don't need that kind of a. So quantum is in such a way because it is a rekindling of analog computing, which we used to be doing long back. It's a combination of analog plus digital and with a multi-layer and multi-parallel kind of computing. So Professor Gokhale, when he returns, we will have another option to hear him. I am his student as well, so I will leave at that. But so we brought in the edge native services to show that how quantum will add to it in the future with the high performance computing. So given that edge and the cloud, native service is what we need, and we need to ensure that these are all the standards are varied standards and they need to be harmonized. So there are challenges to it in the standards. Then there is a challenge to software for real time. There is need computational challenges like compute storage and networking, and then there are challenges to overcome. So the world is nascent in this area. Edge has taken off, and it's a question of what you imagine and what you deliver. And at that, I will stop saying that edge challenges are more than handsful for all the technical and management people, especially use cases drive the industry, and you folks are all full of all the ideas that you need to make uh, world more productive and more economical and more cost effective. And management is the art of it, it is the science of it, it is the essence of everything. So I, with that, I will stop here my uh, professing, as I call it, and ready to get the question answer. Chintan, I think I have been able to hold people to without being quantumish
Arey,
with the
sir,
edge
yes.
and the cloud. Thank you very much. Yeah, go ahead, ask the questions, anything you want. I can
Thank
set
you,
the
sir.
coffee ready.
Definitely. You may stop sharing the screen now.
Yeah.
And I would request everyone to kindly put on their camera so that we can have a face to face conversation. Uh, Great. So now the floor is indeed, I mean, this was something amazing presentation. I mean, we couldn't blink an eye. It was full of information. And sir, one thing I learned as an individual, I learned from you that to deliver a great presentation, you don't need 100 slides. You can do the same thing even with one slide.
Yep. That's
So that's amazing. I mean, I learned something from you, and after so long, I mean, I had attended some other professionals presentation wherein he had only one slide, and he was also able to hold us like the way you have hold us today. So thank you so much for that. And while we open the floor for question, I would request. Okay, we'll start the question. Who goes first?
Yeah, hi, this is Rajesh here.
Hi, Rajesh. Go
Hi,
ahead.
Rajesh.
So, with due respects, I really hated this slide when it was first shown, but then it took some time for me to consume it, and I think you gave us a crash course on many things. Uh, this is my first feedback on this, and I think, sir, one simple articulation would be to give an example of Akamai, where they give you POP services. So if anybody
Mhm.
wants to run an application and if they want their content to be shown all across different places, maybe inside India or outside India, so they give you a POP services. So when you are requesting for that content, the closest POP is where you are and you get served from it. Is that a simple articulation of what you have just told us as far as the edge computing is concerned? You copy?
So, Rajesh, I would comment like this. See, what happens when you see an elephant, you look from different angles and then point out, oh, this is trunk, this is uh,
Yeah. Yeah,
year, and
I've
this
seen
is
I've seen
high.
that. I've seen that slide.
So
Yeah.
edge has been bewildering to everybody. We started definitely in 2013 on the caching, Akamai, because internet needs content delivery, and that was the major challenge for everybody. So how do you do it? Like you do in your computer CPUs, you have got the instructions. It's all instruction set architecture, ISA they call it. So in the instruction set architecture, you have to fetch the instruction, execute the instruction, and once you execute the instruction, it should have done something. Now at the low level, you do only add, multiply, you do logics like and or not and all that. But to build on top of it the application itself, then you need the compilers to compile to binary so that it can run. Then you need on top of it the application itself written in certain language, which you again can translate. So it could be interpretive, it could be compilation. So if you look at that, requires caching, and that is the concept of caching came in. Then when you said, why do I have to do at one compute level, can I do not at the cloud level? And that is where Akamai took it. Akamai took it to the internet all over wherever there is compute, just put cache and cache and cache. Why cache? We could have done even storage, right? Disks, but disks are slow. So it's the IOP, they call IOPs is the rate at which you can process. So your rate of processing improves if you cache it. If you do in memory, then it is very expensive, but still it is worth it because you can do much. Uh, you can cut down the cost of communication. So the cost is a factor. It's a multi-optimization, multivariable optimization. Whether you do using cache, whether you do using compute, whether you do using the frequency to transmit. Like if I want to come to Bombay now, if I take a car and drive, I will reach uh, probably. I may not even reach by the time my life will be over. It could be that. Or if you are taking a ship, you may be able to. And unless like Suez Canal, somebody puts something and then you are blocked, then you will go around and still you will reach. But if you fly, then you can reach faster. So the frequency at which this 5G and all this is, that is why they say millimeter wave is required, and caching edge for that caching is one aspect of it. So it's a multi optimization problem for engineers, and it is a challenge for the use case managers to figure out, uh, people like you who manage the industry, business case. How do we use, what do we use, what technology, where do we bring this to make it really cost effective? So Rajesh, I agree with you. Cache was the first and foremost thing that was brought, that brought the edge computing into us into the edge computing era. And I am talking 2013 when the first commercial version was put out by Akamai. And everybody has been competing with Akamai to make sure that it doesn't take the entire market. And that's the story. When something goes up, AIML goes up, everybody wants to have the pie of it, right? Beauty of it. That's human tendency. That's good because it brings competition. Go ahead.
I'm done. Thanks.
Thank you so much,
Thanks.
sir.
Thanks for listening to our things, and we look forward to again and again. Quantum Professor Saab comes, then you will be totally stumped because I am his fan. He's erratic, but he's very good. That you remember.
Please have mercy for us on your slides. Yeah, they're too intense.
Go
Uh,
for it.
uh, yeah, definitely, and we look forward. So we wish him a speedy recovery as well, and we look forward to have his session in the next month. Rajesh, you have any follow-up question to sir?
So, sir, I'm done. Thanks.
Thank you so much. And now we move on to the next question. Would like to go ahead, Harshvardhan?
Yeah. Thank you, sir. It was indeed an insightful session. As we understand, and we are actually into deployment of 5G core, including IoT gateways. We are in age native architecture with AMF and SMF, as you mentioned in the slide, is already being deployed. I would
Mhm.
like to understand, sir, as we have experienced or learned from the 5G deployments, that age native architecture is actually a major threat to security, and what steps or precautions or prevention should we take it to further be an edge native architecture ready compared to the current cloud native for 5G readiness?
Correct. Excellent question. And looks like Bombay is ahead of Silicon Valley now.
Sir,
Coming to the
sir, before you answer, I'm sorry, I must have introduced all the participants to you. So, Rajesh works with content company and he's the AVP of IT there, and
Mhm.
Harshvardhan is the core lead
Mhm.
for Reliance Jio.
Oh, fantastic. That's good.
So now on, at least request all the participants to kindly share your name and at least describe your work profile so that sir would be able to give you relevant answers to your industry actually while answering. Go ahead, sir.
Yeah. So Harsh, you're Harsh, right? Can
Yes,
I
Yes.
call
sir.
you Harsh? Harsh,
You
it
can
is.
call me Harsh.
Hmm?
You can call me Harsh.
Saru. I'll call you Harsh Bhai. So
Okay.
Harsh, what happens is like this. Okay, Reliance is an interesting company. First thing, they do something. They will. Their chartered accountants generally they do very good work. That's one of the reasons you count money, paisa. You count money very well, and you know where is the economics. So 5G economics, if you try to put the latest and the greatest, you will get ruined because people will, the companies which generate this IPR and all, they will kill you. But the way Reliance has done is interesting because they went ahead and bought a company, Radisys, right? And acquired the technology for 160 million, the whole stuff. Uh, and then, so you got in the 5G edge. Obviously, when we talk about 5G, we talk about releases, release 14, 15, 16. And we are in the 16 right now, 17 is upcoming. In the release 15, you got the standard access and non-standard access, SA and NSA. And standard, so the question is, what is that you have the cell tower? So in cellular communication, cell tower is key. What kind of cell tower do you have? Do you have the 4G cell tower or you have 5G? If you have a 4G cell tower, then it is non-standard access because you are trying to use a 5G new radio NR and trying to access through the 4G node B. So you E node B rather than the G node B. So it started with node B in the 2G era. Now it is called E node B for 4G and G node for the 5G.
5G
Basically, so you are using a 4G backhaul with a front haul which is essentially uh, 5G
NR.
new radio. So in the 5G radio, so what you do is, so in the good old 4G used to have the packet gateway was the key, serving gateway, packet gateway either combined or separate. Chinese separate, Chinese have combined, Indians have combined, US it is separated out. So you can have access gateway and then you do have a MME for the control plane. So there is control plane, management plane, and user and data plane. User data plane are same, but user is a individual, a consumer. A user consumes, but then when you have got hundreds of user aggregated, that becomes data plane because you have to ensure that as you go towards the core from the access from the user, that is the user end to the uh, aggregation level to the core, when you travel then you need to have some kind of a tunnel established end to end to deliver any data. So when you talk of the edge in this case, you've got access management function which is equivalent of the earlier types of VPNs type, where you have a ability to do a AAA and then allow that person to get into the network. So once you are evaluated, then you have the capability, and security is the key in that case. So the question is security, you asked. Why is security important? Because you have to allow only the people who are allowed to, not allow some whatever the intruder, whether it is an inside or outsider. Intruders can be insider, okay? The most dangerous intruders are insiders. Outsiders, you can catch them through firewall, or maybe you can trap them based on the analytics, what the hell they are doing. But the insiders are more difficult because you have allowed the person, so therefore you have to have a authorization so that they don't get access to resources. They don't get kernel level resources to be freaking out on us. So they don't do something which will mess. So security is a zero sum game. Either you get zero security or you get infinite security. You can never implement infinite security. Security is always, it's like if I tell a software engineer, test, I want 100% testing. Can you ever deliver 100%? No, because you don't know how many paths it can take, right? Unless it is a so simple a function that you have not missed anything. Very, very difficult. And same is the security in this case. What do you do? And if you put a quantum computer on top of it, I am killed. Because even before starting, we are assured that whatever encryption, whatever you do, the guys will decrypt in no time. So therefore, how do you defend against quantum computing, guys? If a HPC is put by somebody who just keeps on cracking what you do, it's not simple like replace all by AE, IOE by 1234, or whatever techniques you use for your password. They can always crack it. So it's a question of how fast they can do it. If they can do faster than you can, then you are doomed. So security is really, the best you can do is to make sure best practices, follow them, and ensure against compromise. And if somebody cracks a compromise, you patch it as soon as possible. You discover. So all the big companies from Microsoft to Amazons to Oracles of this world, SAPs of this world, are including nowadays Tencents and Alibabas of this world. All of these, including Infosys and our own Wipros and HCL, everybody has to ensure that they cooperate and do not allow any security holes to be available. And so it's a challenge. I'm definitely with you on that. Uh, Fortunately for us, we know there is a cost, and that is where Reliance is great at counting, to make sure that we secure enough so that it don't get into mess. At the same time, uh, they don't get into trivial issues. Okay, small trivial. You don't kill a guy just for doing some small thing. Okay, that's not what is desirable. You only catch the big fish and make sure that those who are major players who do like let's say national level breaches and all, you address them so that some nation doesn't take advantage of another nation. So you do at a level where it is cost effective and it has minimum impact. Of course, every one Bitcoin somebody takes away, it's huge. But hopefully it is digital currency. That is why it will take some time. But you do see that security is important, and even the Bitcoins of this world, rather Ethereum and all this is going to, you are going to see them as quantum computing comes, it will come. So security is important. Best practices is one way. Doing all the defense from uh, all methods within, it's a AAA, whether it is encryption, decryption, all should be applied. And there is a method to the madness in the sense that you do high priority first and do only what you can at the cost which you can afford. Thanks, Rajesh. Thanks, Harsh.
Okay, sir. Thank you.
Thank you, Harsh. Now, who goes next? Yeah, we have
Sadhya.
Madhu. Madhu, would you like to ask a question? Madhu, are you around?
Yeah, I'm there. No, no, thank you. I'm listening. Yeah, English.
Yeah, Madhu, you'll have to adjust your microphone and put on your camera.
Yeah, I'm okay with this one, and actually,
Milind, would you like to
earlier,
ask a question? Mitra,
yeah, I would like to add what Harsha has asked. Actually,
No, even
5G.
even if you don't ask question, Chintan,
No, no,
even
I just.
Chintan, even if you don't ask question, you can at least introduce yourself.
yes,
Yeah,
yes,
I'm
yes.
Madhu.
So
I'm
that
Madhu. I'm also working for Reliance Jio Infocom from Tamil Nadu.
Mm-hmm.
Even Harsh counterpart, like I can say,
Oh, fantastic.
and good friend of Chintan.
Mm-hmm.
Actually, see, Reliance has not disclosed what they are going to do for 5G on radio front. So only we have core deployment happening, and we do not know what is going to happen on 5G. Whether they are going to change uh, radio equipment, antennas are by E0 B, they're replacing with E0 B. And scope, we know what is the some scope also, but I think it is not disclosed to us. So only we are at deployment, we are at, concentrating on the deployment side.
So put it simple, delta. If your delta is
Yeah,
low, your cost is
yeah.
better, you are going to use that. Okay, it doesn't matter whether you use
They
the
selected
VBBUs
some.
or whether you
Uh,
use the radios, new radios. See, one thing is, do you need to have sub 6 gigi or do you need to get into millimeter wave? That's the question. And most of the cost effectiveness is in the sub 6 gigahertz. So you are not going to get a 28 gigahertz kind of thing. You are going to be in the 3.5 and 5 gigahertz range, or maybe CBRS, which is equivalent of uh, ISM band. Okay, so you are going to be in the somewhere in the sub 6 gigahertz or maybe a little bit above 6 gigahertz. So antenna is the key. So whatever antenna you can get from whatever Indian sources which you have in Bangalore, I believe we have got center of uh, what is it? Somewhere in Bangalore and Chennai there are players. So you are going to get something local, and Radisys software is already there with you. So it's a question of applying. So you need radio, you need antenna. Once you get antenna, the next question is, okay, you got some antenna, you need small cell, or you are going to, and anyway you are tied with Samsung, so you don't have to worry about. Samsung has got enough of that small cell area which you can apply to your 5G. So all you need to know, what is the Samsung product line, what is the most economical, and you can guess what they are going to do. I don't think that you, it's called trade secret. Okay, it's a publicly available trade secret.
Okay, now who goes next? Mitra, Milind, Rohit, Manav, Kajal, Rajesh, you have something to add
So
here?
Madhu, you know Tamil?
no, sir. I'm basically Telugu. I can understand
తెలుగు
Tamil.
తెలుసు లేదు
I, I
ఇక్కడ
can understand because I was there in part of Tamil Nadu for the last five
So where
years.
are you, in Chennai?
Yeah, basically, but my workplace
Tinagar?
is Chennai, but right now I'm in Hyderabad.
Hyderabad, okay. Hyderabad Bund side, Tank Bund, Secunderabad. Yeah, that's also a good place.
I stay near to Tank Bund instead.
Tank Bund, yeah, okay, I know. Gokhale had his Amir Pet, and he used to be there, his in-laws. So.
I stay very near to Birla Temple. You can say like Birla
Oh,
Temple is
okay.
there.
Cool, cool stuff.
Yeah, hi Prakash, Rajesh here once again.
Go ahead.
So I believe one of the known public secrets is Reliance has managed to get that something called the RAN, and that's
Mm-hmm.
a software-based AP which they have
Mm-hmm.
managed to
Mm-hmm.
do, by which they're going to bring down their cost dramatically compared to the other 5G players. You have any
Yeah,
idea
radio
beyond
access
it?
network. RAN
Yeah,
is radio access network, and RAN. So there used to be, so there is something called baseband processing, and there is something called as uh, processing at the high frequency, right? So when you have a antenna which is in the range of let's say 6 gigahertz and sub 6 gigahertz, or somewhere between 7 gigahertz. So it's like I gave you the analogy of going by flight, going by ship, going by walking, and all that, right? So
yeah.
when you have a audio of 3 kilohertz or a Lata Mangeshkar 30 kilohertz types, that is audio. Or if you have a video which has got certain frequencies, so all this is nothing but a superpositioning of the frequencies together and putting that into the wire or putting it into the air, and you trap it and then you access it. So obviously the buying of the radices was very important because it brings down the challenge of IPR. It brings down the cost of ready-made software. So baseband processing is already existing. The only thing they have to add is the radio. So radio is the only thing that need to add it to whatever baseband they are doing in the backhaul. So you can bring a 5G with a VBB use, right? This baseband unit processing, whatever you do at the edge, and using cell tower also, using small cell also. So you can
But
do dense implementation as well as non-dense implementation for rural. Yeah, go ahead. RAN is the key. Software defined RAN. SDRAM.
But I think the simple analogy is like those companies who do not understand firewall, they'll end up buying a commercial box. Those companies who are tech-based companies, they can easily run off a firewall, a software-based firewall on a PC and manage their network. So
Correct.
here, is that what they're trying to do? They will get some Manila boxes and they'll put the software on it and
Mhm.
bring the cost dramatically down. Is that what is the directionally what's happening? Sounds like.
So the cost factor is in the obviously what cost you can give. If you have volume, you can afford to go low. So $200 box, is that a viable option? $200 is equivalent to in India it is like 75 into 200, which is like 1,50,000 or whatever that comes out. So is it in the lakhs? How many lakhs? If I have an internet service provider who is charging 18 lakhs per annum, and for them a 1 lakh box is nothing. So the question is that range doable for a 5G? And if it is yes, that's what they will do. So anything hardware software combination, because volume is important. So cost is not cost for others in the US. US the same thing may cost 10 times. In India you can reduce it by 100 times. The reason is volume, consumer volume, the number of boxes you can produce, and if you do make in India, another aspect where you just bring what you need and then assemble, or even you can go to the level of system on chip with the FPGAs, which is now becoming very popular. So if you are going to do merchant silicon, then you got another aspect. So everything is in a cost factor. Okay, how do you optimize? And it's not just the software, it is not just the radio, it is the silicon, it is the semiconductor, it is also the owning of the fiber optics. Reliance owns the fiber optics all over. Okay, I remember they have dug all
Yes.
over. So all you
Yeah, yeah.
need is the backhaul. Backhaul is simply in your hand. A passive optical network, you just have to light it and just push it in, right? So bandwidth is available at plenty for Reliance, which no other carrier, even Vodafone cannot match it. Even those guys, what is that? Airtel cannot match it. So you have the capability. You give wholesale to them. They in fact depend on you. You don't depend on them. So as a Reliance, you are definitely in a higher, very very advantageous position. It's a question of when to release, when to maximize, how to optimize, and when do you need it really? Is it that people are dying if they don't have 5G? If not, then you don't need to release so fast. But if you think that there is enough market for it, you will be the one first to capture. I can assure you, I have followed the what do you call even the earlier Ambanis at near Express Tower. I used to work, so I have followed those. Man, you got a gem of a guy who know how to manage the finance. So
Great.
cost
And
is the key factor.
yeah, go ahead, sir. Sorry, sir.
Thanks, thanks.
Yep.
Yeah,
Thanks,
and
Anish.
now we move on to Mitra. Mitra,
Hi, Chintan. Hello, sir.
so we
I
have
don't
got
have anything.
today, Prakash, we have got indeed a global interaction because
Wow.
people from Chennai, Hyderabad, Ahmedabad are joining. Mitra is joining us from Bucharest in Europe, and you are joining us
Mhm.
from LA.
Wow.
So
Hello,
Mitra
sir.
is in
Yeah,
Bucharest.
I'm based
So
in.
Mitra,
I'm joining from Bucharest, from Romania. So I'm pretty much here in East European time zone. So
wow.
no specific questions as such, but yeah, it was really nice having the conversations,
So what do you
the Q
do?
and A, and the slides.
What do you do, Mitra?
So I work for a company called ADP. It's
Okay,
the
yeah.
automatic data processing the
Oh, yeah.
company is called. I am part of the. I lead the digital transformation practice, which is pretty much overall into automation and consulting internal
Yeah, I have used ADP for my business
for the
previously.
payroll for the payroll
For the
services,
payroll,
is
yeah.
it?
Payroll
Yeah.
processing, you have to call the phone. ADP, I have to put my 50 people. Now, here is the line 1, 2, 3, 4. This many hours, this many hours, this many hours. You have to negotiate and give them the detail. and then
Right.
they process it and
So
deliver
now,
the
yeah, now we are
things.
building a real-time payment platform where rather than having a monthly salary, what traditionally it used to be, now customers can actually go for a daily pay and a weekly pay also. So the
Correct.
platform will be out in the next couple of months, and then pretty much because that's where anyway the world is heading. So we won't want to, and it also helps you to move companies between months rather than sorry, yeah,
Correct.
within the month rather than at the end of the month.
Yeah, the biggest challenge with ADP, what I had discovered is if you merge and acquire, then you are in a
Yeah.
mess because it takes time to data, right? It's all data.
Yes, yes, yes.
So,
So the
which part
US,
of
yeah, so
the
the US
Romania?
practice is
Mhm.
the North America practice is pretty much still pretty stable.
Stable.
The company has grew up organically, but the rest of the world is there are tons of acquisitions. So there's a huge integration vertical which just builds APIs and manages platform integrations and so on. But I agree, yeah, the other side, the international side is complete. I mean, too many technologies around.
Not only that, you got currency, right? Currency conversion, currency.
Yes,
So you
yes,
got
yes, pretty much.
lira, you got Japanese yen, you got so many things, and Europe is the mother of all standards. They keep writing. They will, if you want something to be preserved, uh, then you have to tell European write the specs, man. Then they will generate a huge specs. Americans
True,
won't
true.
bother about it. Take it, man. Whatever that European, bring that and just apply because they
Correct.
will write so many things.
True,
We
true.
like Europeans. That's the reason.
Yeah, it's fun to work with them.
No, 3GPP. You take any organization standard body is mostly European because European
Yes,
like
yes,
to invest into it, including
yes,
Romania.
but
And Romania is a gateway for Chinese.
yeah, yeah, yeah. No, no. Brussels is keeping the whole EU very busy these days, so it is fine.
Try. Good. Excellent. Nice.
Great.
And Bhola okay, na? You are Bengali? Mitra?
No, no. I speak Marathi. So my first name
मराठी
is
आहे
Mitra.
तुम्ही मराठी निघाला मला वाटलं तुम्ही बेंगाली आहे मित्रा इज अ
No,
गुड नेम बेंगाली नेम यू नो
yeah. Yes, that's right.
enjoy it's good
Thank you.
it's
Thanks.
night it's a night for you late night or what is
No,
it
no. It is 4 p.m. So I am about
okay
8 hours ahead of
okay
Pacific time zone.
okay okay 8 plus 8 okay got it
+8. Yes.
okay,
Do
good
you have any questions from Manav, Kajal, Milind? If not, then we move on to AT
no
sir. AT sir.
yeah go ahead ask them to introduce themselves even if they don't
Yeah,
have a
at least
question
Manav, Kajal, Milind, introduce yourself.
opportunity to interact communicate network come on get a
So you scared
they're
them with the
shy I
slide.
think they're shy
No, you're shocked them with a slide, yeah.
no. I'm not shocking. I want to hear because world is uh, so much connected these days. It's impossible to not know our people from all over places.
Yes,
We
sir.
miss the opportunity if we don't do what we
Hi,
communicate.
can you hear me?
Yeah,
Yeah,
Yes,
Milind,
yes.
go
Milind.
ahead. Yeah, Milind,
Yeah,
go ahead.
just I would like to introduce myself.
Mhm,
I
mhm,
work with Capgemini India. I work as a program manager here, and I work for automotive and manufacturing sector,
mhm,
and mostly into ERP. And I'm also developing a product, cloud-based product for SAP.
mhm.
So I'm working as a product owner there. So that's in brief. Unfortunately for me, this subject is not very. I mean, that's not the area wherein I've worked in. That's why I try to keep quiet. But I'm happy to be
No,
happy
your
to
HANA is there.
introduce.
SAP HANA is there. I can see that. You are not
Yeah, yeah,
away from your SaaS is not SaaS bani ban gayi bahu, they say, right? So SaaS has become now nativized, cloudified, and then from cloud to cloud native it is coming. And it will come
correct,
to edge.
correct.
So you have
Yeah,
got
yeah.
all the now where are you in SAP? R5, R6, R7? What release you are in?
I work with SAP directly for their product development. So
Mhm,
I work on all their latest infra.
mhm. Yeah, infra is HANA, right?
Yes, yes. and I'm working on. I'm developing a product which is on SAP Cloud Platform.
Mhm. So, do you deal in the production planning and management, PPC, whatever?
I do deal in logistics and supply chain, including production planning as well.
Okay, so it's all supply chain, back order, and all that. How was supply chain this time? It was very disrupted, right? How did you manage?
Exactly.
The supply chain was the worst affected in the COVID-19 time frame.
That's right. That's right.
So, do you deal with the auto industry? So, is it like Tata's type of
So
telcos?
I got an opportunity to work with customers like Peugeot, Citroen, some of the projects which we are doing. They are in, with BMW and
Oh,
few other
BMW.
global
Yeah.
automotive OEMs as
Yeah.
well.
See, German based, right? SAP is anyway European,
Yeah, yeah.
and BMWs of this world, they definitely want it. Actually, SAP was the major process control player, chemical industry. They were the ones who brought all this. SAP was based on chemical industry, all the process control. In fact, they were the one who are currently industrial IoT best place to take advantage of it.
Okay.
So edge computing for industrial IoT, which is part of this manufacturing, like GE is another player who is positioned well for aero industry and those kinds of things. Similarly, SAP is the one which will gain the maximum out of pharma as well as drug discovery, as well as the automotive like BMW, which is there in Munich, I think. Munich has got that close to Munich. They've got a huge. I have visited that place. It's a there. BMW is real great, man, and SAP is all over there. Good, good, Milind. Thanks for your introduction, and we like to
Nice
hear
to connect with you, sir,
different things from
and
different
thanks
players.
for an excellent session as well.
Yep. Go ahead.
Thank you so much. I guess Kajal, are you available? Kajal, Manav. Okay, seems they are not around their machine right now.
Mhm.
However, so now it's my pleasure to introduce Flight Lieutenant A.T. Kishore. And he is, apart from all his various technical stints,
Mhm.
he is also part of IEEE Bangalore section.
Oh,
And without much of ado, AT sir, over to you.
Thank you, Chintan. Sir, Prakash sir, do you hear me? My
yes,
voice is.
Lieutenant Colonel, I
Oh,
have to salute
thank
you.
thank you, sir. Thank you very much, sir. So, yeah, interestingly, for those of you about the ranks in military, I think 24th March, Government of India made a announcement that all of you who retired, you can actually keep your ranks. So, in
Wow,
fact,
cool.
no need to say retired or something. As a veteran, you can just mention. And that's something they have resolved in a parliament session and signed on 24th March. Interesting, sir.
Fantastic,
So I
fantastic.
actually relate with the way you have been connecting even after your talk with all the attendees. And
Mhm.
that's very like Atmiyata. Like, for example, SAP. Recently, I got been introduced to one HTC Global, HTC Inc. These
Mhm.
guys champion on the SAP's practices and they deploy services.
Mhm.
And so I can relate some of your conversation about how SAP
Mhm.
relates with industrial IoT and industrial automation. I'm also
Mhm.
associated as a factory.io, which is
Mhm.
a startup, New Delhi based startup, and
Mhm.
with many of their leaders from Andhra Pradesh.
Mhm.
And so the factory.io aims to deploy all the power of IoT and sensors and AI ML,
Mhm.
including ERP and HR databases of the
Mhm.
supplier ecosystem. If you are manufacturer, yeah, Rajesh, yeah, Rajesh, you have something?
No, no, sorry.
Thank you, Rajesh. So, the if you are manufacturing a product, for example, the 5G based station, then you will have the suppliers like tier one, tier two, tier three suppliers. So if there is a knowledge or intelligence which you can incorporate into your decision structure, then you can effectively make sure that you can scale up properly and not have the surprises towards your flow. So as we discussed about Reliance use case of bringing out 5G base stations, as you mentioned. So that is one context, and another is in IEEE, as Chintan mentioned, the topic of yours, sir. There is one PAR standard approved, and we are going to announce the results in an year from now. We have got time, and that's called the IEEE P 1931.1. And if time permitting, kindly look at possibility to be our contributor, because the aim of that standard is to look at the edge aspects of the stack. And the name of the standard is real time on site operational facilitation. And in summary, it is like a roof computing, and just like fog computing and edge computing.
I
And there
see.
is one Shyam Madanapalli who works for NTT Docomo, who is right now in Dell US. He is one of the chairs and contributors, and the other team members are there. We have regular meetings, and I think one of them happens in today being third. I think fourth, fifth, there is a meeting for a review of what is happening to that IEEE 1931.1, the topic of edge computing and those aspects. And the questions asked by Rajesh and other telecom experts like Madhu and other Harshvardhan. So I think what I can see is either if it is Samsung or Nokia, their 4G, 5G roadmap will be, they don't touch the 4G, it will continue to be there for a quite long time, sitting side by side along with 5G. So 5G will come and sit as additional small radio on the top. So they don't need to invest more on the towers. And as you said, sir, the Indian government already allocated 3300 to 3600 for the sub 6 gigahertz for 5G. And I think millimeter waves, though it is attractive from research point of view, as you know that the performance is more better in that towards the lower edge. I think India has never been using 700 megahertz. Even when the world has started talking about TV white spaces, I think that is where miracles can happen, and Reliance can do more wonders there. Being the pioneer in the research and all, as you mentioned about Reliance acquisition of
Radisys.
Radisys, and then other competences it has in IPs. I have one Dr. Dilip, who is IEEE person, mentions about the possibility, as you mentioned about sharing of information across all the players. So there is a, and while sharing it, to ensure that the data is not compromised, there is a possibility to use, as Chintan is also one of the top 50 thinkers in the blockchain. I think for the security layer, blockchain based implementation for 5G edge might be the kind of the new normal that when it comes to deployment. In fact, we enjoyed Oliver talk, and then it's not. In fact, there is one company. I think Jeff Bezos has banned slides from his employees, and also there was a talk wherein he said, not very long ago, he told the CEOs, don't waste your time on refining PowerPoints. Do your job. Your job is to defend your company, strategize. So something like Porter's five competitive challenges that they need to focus on. I think your one slide has summed it all, and fantastic talk, sir. And we enjoyed even the conversation thereafter. And congratulations, Chintan. Recently, he announced from May 2020, within less than a year, he was able to attract from the venture capitalists, and his firm is also leaps and bounds. It's growing. So I think we are all doing good, and the combination of technologies, management, and innovation, that is the thing that is needed in right composition. And so, in that context, our talk has really illuminated, and looking forward to interacting with you more. Thank you, Chintan and TMI community for this opportunity. Thank you, Prakash Ramchandran ji. Jai Hind.
So, Chintan, I take one.
Yes, sir.
Kishore, sir, firstly saluting you. uh, for the services you give to the country, and you deserve to be a part of this community as well as part of the Indian progress for the 5 trillion. Uh, and IEEE, I am the co-chair of EAP, Edge Automation Platform. We are renaming it as Edge Service Platform. No, it's service automation, because the aspect of automation is more towards industrial IoT, like factory.io you mentioned. Okay. And the blockchain definitely is a security uh, tool, but focus mainly on transactions, non-fungible uh, digital assets, etc. You can possibly use for it, but at this time, it is not going to be able to get anything on the physical aspects of it. It will take more time on that, and because decision support systems are not same as transactional system, blockchain application for transaction application has a greater value. Yeah, okay, like example, we have what you call as certificate x.io, and that we are trying to have for Delhi University all the digital certificates being issued so that you don't fake it. So a transaction which goes together with a bunch of uh, transactions, which is where the block is, and the block at the chain level are connected, and you don't want anything to be written. Once written, it's recorded, and that remains. But if you change the blockchain, you want to edit, then you are in for a fix. So that's why we have to track everything. So blockchain is a value for security for transactional aspects or transactional applications. Coming to another one, sub 6 gigahertz, which you mentioned, 3330 to 3360, whatever that band. You for 5G, you need to 100 megahertz band, baseband. For the 4G, it was 20. So at least 5 times. So 5x bandwidth. That means it's more wideband. And if it is more wideband, you can go with a lower power. And if you can go with lower power and also different frequency. So question is of processing, and you always process at the baseband level. So baseband is going to be that 100 megahertz range. Whatever your higher frequency may be, whatever you put, 3330, or it could be even millimeter wave, doesn't matter. This was just a matter of conversion. And once you convert, then it's a computation. So certainly we see Reliance is well positioned for it, and so are other companies. It's simply a matter of who acts when. And COVID really accelerated a lot of digital uh, transformation, and now the operational transformation, knowledge transformation will require 5G. So it's a question of when it becomes business critical, it will come. Yep. And
Thank
thank
you,
you for
sir.
your participation. I'll see you. I'm
Definitely.
connected with all Chengappa, if you know, IEEE, Bangalore.
Yes, 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 yes.
And so I work with him on several things, the CCICI and all that.
Right.
Pamela
Cloud
and
computing. Yes, it's
yeah,
Pamela Kumar.
yeah,
Yes, it's
Pamela
Director
Kumar
General,
and
TSDSI. Yes.
yeah, Mr. Krishna Kumar and all these. I know the whole group because I am part of their AGM, whatever they call.
Thank you.
Yeah, thank you very much.
Great, great. Thank you so much. Indeed, this was one of the informative session, and then there is feedback as well that people would like to rewind it and then watch it. So Uttam Maneji, who was earlier in IT team of what you call MSCB. So he was a senior person, senior IT Maharashtra Electricity Board, has requested for the recording because he would like to hear it once again so that he can digest it well. And so these are the kind of feedback we have. Thank you so much, sir, for this indeed enlightening and informative presentation. We look forward for having more and more such engagements between TMI and OTF, wherein members of both the communities would benefit to a greater extent. Thank you, sir, and we look forward for the next webinar on next Saturday. The next webinar would be by Professor J.J. Raval. So, in terms of space research and astrophysics, he is one of the iconic personality. So, he is going to deliver a session for one of us next Saturday. So, until then, have a great evening and a great Sunday ahead. Thank you, Prakash sir, once again for engaging and sharing your knowledge with us. Thank you, sir.
Thank you.
Thanks everyone, and look forward to next TMI
Sure.
next week. And we definitely
Thank you.
want to have a good collaboration with people. Thank you very much. Thanks,
Thank you, sir.
Sridhar.
Thank you.
Thank you.
Thanks,
Thank
Thank
you.
you.
Vidhu,
Bye
and
bye. Thank you.
Rajesh, and Harsh, and
Bye bye.
all the people who participated, Kishore, and